Hello, my name is Berger. This is my submission for Lab 3, Black Hole, in the course Physics 2211, Dr. Claire Berger. The purpose of this lab is to determine the forces acting on a star and use that force along with the mass of the star and the distance from the star to the black hole to ultimately determine the mass of the black hole. With this known mass for the black hole, we can then find an initial velocity for a spaceship such that the spaceship becomes very close to the black hole, but is still able to leave. Here we can see a preview of the results of the lab. The main physics principles used in this lab are Newton's second law, Newton's law of gravitation, and force decomposition. Here we can see Newton's law of gravitation. Here we can see Newton's second law, and here we can see force decomposition. Before heading into both parts of the lab, the system, surroundings, and initial conditions must be identified. For part 1, the initial conditions are set here. The system is the star, and the surroundings are the black hole. For part 2, the initial conditions are here. The system is the spaceship, and the surroundings are the planet and the black hole. This is the code for part 1. Here we can see the C that I've generated with my GT email. Next, we can see our initial conditions here. And here we can see a loop that calculates the mass of our black hole. For each iteration of the loop, an initial and final velocity are found, and this is used to calculate an initial and final momentum. With initial and final momentum, the change in momentum over time can be found, and this is set to F net. The portion of the loop highlighted essentially uses the force decomposition and implements that into our code to calculate the F net force. The net force, we can easily calculate the mass of the black hole by rearranging Newton's law of gravitation. Here we can see our code run. And the mass of our black hole is right here. Here is part 2 of the lab. We can see our initial conditions set here, and notice that this black hole mass is the black hole mass calculated in part 1. For each iteration of this loop, we are calculating the net force on both the planet here and on the ship here by rearranging Newton's law of gravitation, as seen in all of this code. Then, using Newton's second law, we can use the velocity update formula as well as the position update formula to update both the position and velocity of the planet and the ship. Then can use the guess and check method to find an initial velocity such that this spaceship does not get stuck in the black hole, shown here. Here we can see our code run. And we can see that the spaceship does not collide with the black hole nor the planet. And we can see the distance away from the black hole. Possible sources of error in part 1 include rounding values throughout iterations of code by the computer, rounding of the value g by using 6.7 instead of 6.67. And lastly, although not an error, the final mass is an average of the masses due to slight differences of mass values throughout the code. And that is referring to the mass of the black hole through each iteration of the loop. As for part 2, the errors include a rounded value g, as mentioned earlier, and a guess and check method of determining the initial velocity of the spaceship. The net force and its parallel/perpendicular components are mathematically equal to the rate of change of momentum in its parallel/perpendicular components respectively. However, in order to calculate the net force, the mass of the black hole as well as the star must be known, which it is not in part 1. Therefore, the rate of change of momentum can be used to calculate the net force and its components in order to find the mass of the black hole. What if? In order to orbit the black hole, we need to change the direction of the spaceship's initial velocity. In part 2 of the lab, we can see that the initial velocity was set almost in the direction of the black hole because we wanted to get as close to it as possible and still survive. But now that we want to orbit the black hole, we want to move this trajectory to be almost tangential to the orbital path shown here. So here we can see the spaceship in orbit. And this was our orbital velocity that I found. using the guess and check method. Here we can see the orbital velocity run. And that wraps it up for lab 3, black hole.